Students, today's video is about the qualities of quadrilaterals. You know, quadrilateral is a polynomial with four sides. When the lateral sides are joined end to end, we get a closed figure which is called a polynomial with the four lateral sides. Now these two sides are called opposite sides and these two sides are another pair of opposite sides. This angle and this angle becomes adjacent. These two are adjacent, these two are adjacent and these two are adjacents. This angle and this angle becomes opposite angles. Sum of all the angles form to 360 degree. Now this is a trapezium, a scalene trapezium. That means all sides are of different lengths. So this length is different, this is different. So this is a scalene trapezium. Now since these two sides, opposite sides are parallel, look at this and this angle becomes co-interior angles. What about their sums? They sum up to 180 degree because they are supplementary, that you know in the case of parallel lines. This becomes a transversal when these two are parallel lines. So is the case, these two angles becomes supplementary. They are co-interior angles. So this is about the trapezium. The diagonals of the trapezium, they are not equal because no measures are equal. Now taking up the quadrilateral, which is named as kite. It looks like kite. Now these two adjacent sides are equal, another pair of adjacents. So here in a kite there are two pair of adjacent sides are equal. Now the opposite angles is found to be equal. Now look at the diagonal. The diagonals aren't equal. This is the shorter diagonal and this is a longer diagonal. See, the line joining the two non-consecutive vertices of the quadrilateral are called diagonal. So one diagonal and this is another diagonal. See what happens when the diagonals intersect each other. When the diagonals intersect each other, they form 90 degree. What it means? They are perpendicular to one another. Now are they bisecting? No. This length is very long. This is shorter length. So they are not bisecting each other. This is about the kite. Now let me repeat. One pair of adjacent sides are equal in kite. Now I will take up another quadrilateral which is called rhombus. See, this is the rhombus. Here all sides are equal. In the rhombus all sides are equal. Then is it a square? No, it is not a square because here the opposite angles are equal. These two opposite angles are equal. Not all angles are equal. And this angle is found to be obtuse and this is also obtuse. They are equal in measure. This is acute angle, then this is acute angle. But these two opposite angles are equal in measure. So in a rhombus all sides are equal, opposite angles are equal, and then the sum of adjacent angles is found to be 180 degree, that they are supplementary. These two angles are supplementary, these two are supplementary, these two angles are supplementary as well as this one. Now let us see about the diagonal. See, I have two diagonals. These two lengths are different. Now I keep here the diagonal 1 and this is diagonal 2. The diagonal 1 and diagonal 2 are not equal. They are not equal. But see, look at the angle formed here. This is 90 degree, this angle is 90 degree, here is 90 degree and here also it is 90 degree. So the diagonals in the rhombus are perpendicular to one another. And about the intersection, see from here to here it found to be equal length. So the diagonal are bisecting each other. Now this from here to here it is equal measure and here to here it is equal measure. So at the point of intersection, here it forms a 90 degree. See, right angle triangle, and when the side of the rhombus becomes the hypotenuse. The problem comes in higher classes, so you have to keep in mind that in a rhombus, once the two diagonals and the side forms the right angle triangle. Okay, so I'll just conclude. In a rhombus, all sides are equal, but not all angles are equal. Only opposite angles are equal, and two diagonals bisect perpendicularly. Let's come to the square. This is the square. Now, see, in the square, when you compare to rhombus, see, all sides are equal. Here also all sides are equal, but here the angles are 90 degree. All angles are equal to 90 degree. Now, by diagonals, see, these two are diagonals. They are, say, equal in length. So, I keep here one diagonal and another diagonal is kept here. So, they are intersecting at point. Now, at this point, the angle is 90 degree, and the point of intersection, this is the point of intersection. From here to here, here to here, the length is same. Here to here, here to here, the length is same. So, what you can say is, in a square, all the both the diagonals are bisecting perpendicularly to one another. So, I conclude, in a square, all sides are equal, all the angles are equal to 90 degree, two diagonals are equal, bisecting perpendicularly. Now, taking another this one is a parallelogram. Look at this. These two are the diagonals. See, the opposite sides of the parallelogram are equal and parallel. These two are equal and parallel. These two are opposite sides, equal and parallel. The opposite angles are equal. These two are opposite angles are equal. Now, taking the diagonals. See, the one length of the diagonal is shorter and the other one diagonal is longer. I keep here. This is the longer diagonal and this is the shorter diagonal. When the diagonals, see, look at this, it's at the point of intersection, the length of the diagonal are equal. So, this is bisecting. Not equal, but bisecting. Okay. So, in the parallelogram, the diagonals are unequal, but they bisect each other. So, see, a parallelogram can be turned into a rectangle. Now, let me change the angle. See, I have changed the angle. Now, it forms a rectangle. How is it? All the qualities of the parallelogram are with the rectangle. See, opposite sides are equal, opposite sides are parallel, and the only difference is the angles is, all the angles are 90 degree. And in the case of parallel rectangle, the diagonals are equal. See, these two are the diagonals of the parallel rectangle. They are equal in measure. I keep over here. This is one diagonal and this is another diagonal. Say they are equal at the point of intersection. The length from point of intersection to the vertex and point of intersection to the other vertex, they are equal. So, they are